Hello again everyone. In this video, let's talk about file types. So, what is a file type? In general, all the files in our computer can be divided into two groups. Those are text files and binary files. Let's open the file again, the life of B, in our Nano editor. So files like this that we can open in a text editor and read and make sense to us, these are called text files. They are also called human readable because of this property that we can simply read their content when we open them. Actually, if we were somehow able to open up the disk and read the contents of this file exactly from the disk, we would again see the very same content. The text files are stored in disk as a sequence of their characters. So for example, this file in the disk is actually composed of these 1, 2, 3, 4, 5 new line characters, which is the name of the enter character in the context of programming languages and files and operating systems, followed by a capital P, then a small r, then a small o, all following each other in sequence until the very end of this file. So a text editor such as Nano or Vim or Emacs, or for example Notepad in Windows or Gedit in Linux, that's a very simple program that just opens the file in the disk, and whatever the contents are, it shows the contents to us. And since the text file is already human readable in the disk, then when we open this file in our editor, then the contents are just meaningful. For a text file, it's completely okay and even expected that we open the file in a text editor and read and then make changes to the file, like we have done in the last video, deleting the header of this file. Text files are just supposed to be changeable by the user. However, not all files are like this. Some files are just not meant to be opened and read in a text editor. Those are called binary files. So, here's a challenging question for you. Can you think of a binary file example? Why would a file be binary, for example, rather than being a text file? As an example, let's download an image file. So, if we go and search for this XKCD comic on operating systems, which is the comic of the week, and download this image file to our computer. Yes, here we see the image file. I also want to see the extensions of these image files. If I, for example, if I hover on this file, then the system already shows me that this is a PNG file, but I want to see the file extension explicitly. You can do this in Windows 10 by going to the View tab of the File Explorer, and here is a checkbox, File Name Extensions. So clicking it will give us the operating system tox.png, so it will show the PNG extension. In the older versions of Windows, you can go to the Start menu and search for Folder Options, and in the View tab of the Folder Options, you can unclick this Hide Extensions for Known File Types and then accept it. And then now we are able to see explicitly that the file extension for this file is a PNG. So, a PNG file we can just open. Now the Photos application in Windows has opened this file. So for example, what happens if we try to view this PNG file? We can download that file directly to here, our directory. If we copy the image location, now we have the file here and try to open it using Nano. Now we see some weird characters that doesn't really make any sense to us. There is this control-like character here and some edges and some rectangles, which actually mean that the editor is not even able to display this strange character. Basically, this file is not understandable, not human readable for us. Such files are called machine readable. This file actually has these PNG letters at the beginning. This is called the header of the file. This part usually summarizes what kind of file this is and the format. This is useful for the program that is going to try to open this file. There is also some content that actually happen to be human readable, but as long as there are these non-human readable parts, this is still a binary file. So let's make an experiment. Let's go to some place in this file and, for example, write some characters. And let's save this file as the edited version and exit. And I will copy this newly edited file back to the Windows side. And then if I try to open this edited file, now we can no longer open this file. The Photos application expects a certain PNG format, but we just went in and made some random changes with the editor, and now it doesn't anymore conform to the expected PNG format, and it cannot be opened by any application that was supposed to be given a PNG file. So it just gives us the error that it looks like we don't support this file format. Therefore, binary files are not for us to go in and change as we like. They are for these specific programs to save them as conformed with their format, and then for these special programs again to go and display them. Let's, for example, also see another example image file. For this, you can go to the command line course, our web page, and in the materials section you see some files here. I will first start by downloading this JPEG file, download it to my directory here. So if we go and open it, it is this JPEG file again, and if we download and try to open it from Linux, the JPEG, then again we see these gibberish characters that we can't make sense of. So we have now seen an example PNG file and an example JPEG file, and both of them were binary files. So are all image files binary? Not necessarily. It is just very common for image files to be binary, but this is not mandatory, this is not a rule. So here's another question for you. Why do you think most image files would be binary? Why not just keep them as text files? The answer is twofold. First, we usually don't need to change the image files by opening them in text editors. That is a very unusual scenario. Usually what we do with image files is we view them in dedicated applications like Photos or GIMP or Paint. And if we want to change them, then again we use these dedicated programs. For example, we can open the image file and change its colors or apply a filter using the GIMP program. GIMP already knows this binary file format and saves the modified file accordingly. So we are not doing any manual changes using Nano or Vim or whatever. The other reason is that image files are usually big files. We will be talking a bit about file sizes in the next videos. an image needs to encode every pixel it has so that it makes a meaningful view for you. But this is a lot of information. They are usually much bigger than regular text files which just hold the characters that we want to read. So, for image files to be stored and transferred effectively and easily, compressing them in terms of size is very important. And how you compress them is actually an important question, and that's why we have several binary file formats like PNG or JPEG or else. So different image file formats use different tricks for compression. An interesting fact is that this is how the JPEG files came to be invented. When the web browsers were new and network speeds were really slow, downloading images or actually opening any file that includes an image in the internet was a really big problem. We had to wait for example, minutes for an image to be able to be viewed. That's why JPEG came along as a compression format specifically for images that were supposed to be displayed on the internet to make them more feasible to be opened in real time. However, this does not mean that all image files are binary files. As an example, let's go again to the course web page and download this SVG file. SVG is one of these famous text-based image formats. We can view this SVG either using a dedicated program like Inkscape, or you can as well open it using a web browser, for example Firefox. So this is the exact same image in SVG format. And what happens if we go and download this file here and try to open the SVG file? Now we can see that there are no gibberish unreadable characters. An SVG file is completely human readable, and actually parts of it make sense. For example, there are some X and Y here, and some kind of names, and some information about the version of this XML format. This is actually a trick used by the SVG files, which is short for scalable vector graphics. An SVG file doesn't draw an image, it describes an image so that we can view the image in whatever resolution that we want. For example, as a fun experiment, let's search getting started with SVG files in the web browser, and we will use this link from developer.mozilla.org. Here is a simple SVG file example. Let's copy this and open up Nano and paste these contents. And I will write out these contents, naming them, for example, magic.svg. And I will exit this. Then I can copy this magic.svg to my Windows part, and from the File Explorer, now if I try to open this file with my Firefox, then I see an image, because actually this SVG file, this described us how to draw the image. It says make a rectangle with this width, with this height, and with this color, and put in a circle to this center X and Y coordinates with the radius of this and the color of this. And this is actually how we happen to visualize the file. So that's it for now for image files. We have seen both binary and text examples of image files. So another question for you. Here is a docx file in the materials. It's a Microsoft Word file. So do you think a Microsoft Word file is a text file or a binary file. Let's download it also to our Windows and open it. This is the contents of the file in my Microsoft Word. And to check if it's a binary file or not, I can also take this file here and then try to open it with Nano. And I see a lot of gibberish. So this is the answer. A Word file that has been created by Microsoft Word. It's not a text file. It looks like it holds text to us, but actually a Word file holds so much more than that. For example, I can as well go ahead and make parts of this text bold, or I can write a line, or I can change the font of this text. So there is so much more information in this file. It is in disk. It must be keeping much more than only the characters I and F and space and Y and O. It actually holds how these characters are supposed to be shown to us. It should hold the color and the typeface and the alignment. So for example, if I save this file and close it, and then I go and again open this file, I can see this file exactly as I have just formatted it. So all this information was actually dumped to the disk in some way. This is much more than the bare bones text file, which only holds the characters of the text and nothing else. As another example, let's download a PDF file this time. For example, I decided to download a PDF about dinosaurs because I have always been curious about dinosaurs and I think I can learn more, and maybe you have been curious as well. So let's save this link. This is the PDF file. So I can go and copy that file as, for example, dinosaurs.pdf, and I can try to open that PDF, and I see again that it's composed of all these unreadable characters. Again, this PDF has this kind of header. It also explains, for example, that this is a PDF version 1.5. There are multiple versions of PDF, so this header is already giving us some information. Before we end this video, let's talk about two more important points. The first one is that .txt file, as we have seen here, are text files, but those are not the only text files. Another very important class of text files is actually the code files or the script files. So the code files that we write our code, for example, in C, Python or Java, or script files like Bash or Python or Perl scripts, they are also written as text files. We will talk about them in detail in following weeks as well. Because the purpose of a code file or a script file is that you open the file, you write your code, you change your script, and then you run it again. So the idea is that we should be able to open our code in a text editor and able to change it. So for example, if I'm writing a code and I decide to write that in Microsoft Word, this doesn't work in practice because Microsoft Word is going to save this file in the docx binary format, its own format, and we won't be able to run or use this code file as we like. What we should do instead is write and edit our code in a text editor. This can be Nano that we have been using, or Vim or Emacs in the Linux shell, or Notepad, which is the default text editor in Windows, or TextPad as a more intelligent text editor option in Windows again, or Gedit as one of the default text editors in Linux. But any program that we use for it must be a text editor. It mustn't be using its own fancy format to somehow keep the file in a formatted fancy way like Word does. The second point is about these file extensions. The file extension is the part of the file name that follows the .txt or .pdf, or now you can see from our file explorer now that we have allowed the file name extensions. So the .pdf, .svg, these are called the file extensions. A file extension is not mandatory for a file, but it's actually a clue for your operating system to know which program to use to open your file. For example, here from Life of B, we can remove this file extension. Like for example, I can copy Life of B to a extensionless version, and then again go and try to open this new version in Nano, which is completely okay because we didn't change the contents of the file. This is still a file that Nano is able to read. This is still a text file. And for example, I can go and change the file extension here in Windows. For example, I can remove this docx. When I try to change or remove the file extension, Windows always gives me a warning saying that the file might be unusable, and am I sure that I want to change this? I will say yes to this. So now, when we try to open this file, then Windows has absolutely no idea how to open this file because we have removed the clue that this is a docx file and that Windows should use the Microsoft Word to open it. But if I'm okay with going and selecting the program to open the file myself, then this is completely okay because the contents of the file haven't changed. It's just the naming convention, the clue of it was removed. The takeaway here is that a file doesn't have to have a file extension, and indeed some files traditionally don't. Most notably are runnable or executable files. We will talk about them more in the forthcoming weeks as well. These are generally the program files that we run in our system. But on the other hand, for other files that are not these runnable executable files, it's in general good practice to give them extensions. The idea is that, for example, when we open our directory, then we immediately see what kind of file it is. Or for example, when we ls here, then this lifeofb.txt is more meaningful than life of b because we have no idea what this life of b can be, and we need to open it up and check what the contents every time, for example. So it's in general a good idea to keep our files with extensions unless it is one of these files, the runnable executable files that are traditionally used without an extension. Let's try something else also to end this video with. So for example, let's change the file extension of this magic svg file to magic.txt. Again, there is a warning. And then the image has changed because now Firefox, the Windows doesn't know anymore what kind of file it is. It just thinks that this is a regular txt file. But if we go ahead and open it again using Firefox, then Firefox gives us just the contents of the file instead of showing us the image, because the extension is also used sometimes by the programs, especially with programs like Firefox that can open multiple type of files, as a clue of how to interpret this file. So when this was an SVG file, Firefox was thinking that this is an image file, so it drew the image for us. But when this is a supposedly TXT file, then Firefox thinks that we want to read this file, so it displays the textual contents for us. In all these cases, the contents of the file is never changing, but how to open the file and how to interpret the file can be different depending on the extension. So, hopefully you enjoyed this video, and hope to see you in the forthcoming videos.